Hey, Prince here, and today we're going to talk about Gemma, and I'm going to show you a code example on how to run Gemma locally on your laptop. So Google just announced Gemma. Gemma is a lightweight family of large language models, open sourced by Google, meaning you can use it commercially or for research purposes. And the model comes in two sizes, particularly a 2 billion and 7 billion size. So one thing that is quite interesting is that the 7 billion parameter model actually outperforms Mistral 7B, which was the previous king of open source. For today's tutorial, we are going to summarize the Google's Gemma report using Gemma itself. So the first step to run this model is to download them locally in a format that you can run in our local environment. And in my case, I'm running a MacBook M1. So that means I need to use something like a quantized version or MLX, which already has all of these abstractions built in. And MLX is actually a library by Apple Research that it optimizes to run on Mac Silicon. In that case, you can come to the MLX community repo on Hugging Face, and you will notice that there are already a few contributions here. You have the MLX quantized Gemma 2. This is the base model. This model is not instruction tuned, and also the same here with the 7 billion parameter. And earlier today, I actually contributed this version here, the instruction versions of Gemma, to this repo, so you can find them by adding an IT to the end. And you can just come here also as well, check. You can see here that this was me, Prince Kanuma. Okay. So the way you can run these models is using MLX itself. This button here doesn't really show you the actual code, the correct code to run this, but we're gonna get there in a second. So let's go to our environment. Here we are. So the task today is to summarize the report using Gemma, and the tools we're gonna use are Hugging Face and MLX. So the first thing you do is to install LangChain. Actually, you don't need the LangChain community, you just need LangChain, the base LangChain. You need PyPDF to be able to read the document. You can actually skip this text generation here and skip LangChain OpenAI. This was an experiment I was doing. I will come back to it and finish it. And after that, you just install MLX. You'll also need Hugging Face Hub and Hugging Face Transfer. These two are going to be essential to downloading these models. So you can create here pip install, and we also want the last versions. And the reason why I commented out is because this is mostly for GPUs. If you're running let's say a Windows machine or Linux machine with NVIDIA GPUs, you might want to use this line and comment out MLX. And then after you run this, I already installed this library, so I'm not going to repeat that. You can just run this. This is going to install these libraries here that you need. And once you have those, you can import MLX LM. And the first thing we're going to import is the load function, which is going to download the model and load it, the model and the tokenizer and load it. Then we are going to use the generate function, which helps the model generate. It's an abstraction to generate results. So it makes it easier. You don't have to create your own loop. This already does it under the hood. And we also define this environment variable here so that the download is faster. Once you run it, for me, it's going to run really fast because I already previously downloaded this model. The model is now loaded. Here is a chat template. So the instruct version of Gemma takes a particular format, which is basically start of turn, role, new line, content, and then end of turn. And this is actually described in the report. We can actually come to the report. It's described somewhere here. There we go. So these are the supported instruction tokens. You can see here that it takes a model and a user, and this is to start and this is to end. Okay, now going back, once you define this template, I'm using Ginger here to kind of format my input. Now that we have that, we can actually just use the OpenAI API standard, which is basically content and role, and we can pass that here. Once we have that, we pass the model and tokenizer and the prompt to the generate function, and this is gonna generate everything for us. So in this case is respond like Snoop Dogg, who is Einstein, and this is running locally without access to the internet. So you can see here it's generating the response. It's pretty fast for an old M1, and it did 7 tokens per second. I think that's because I'm using a lot of apps right now. By default, it does around 11 to 12 tokens per second, so a little bit faster than that. But you can check the output. It says, yo, check it. Einstein, the GOAT, the smartest dude on planet, Einstein the genius. So it's kind of creating this rap song or verse about Einstein. Pretty cool. But now moving on, we want to load that document. I already previously downloaded the report. It's already here. So we are gonna create our load function using LangChain, and LangChain community is involved. So you might want to also put back LangChain community here. It seems like we're still using it. Okay, so now that we have that, we can load our create our load function, which basically just loads the PDF. And if any chunk, any page has more than 500 characters, it will create smaller chunks so that we don't overflow our context window. Then we just pass the name of the model, the type of the document, and it's gonna load. And here we have a list of all the pages. So this is page 1 that has the date, the team, and all this other information. And you can notice that it also says here, Gemma repeats this Gemma models based on Gemini research technology. If we look at the original file, you can see that that's actually here. So it's not a bug or anything. It's how the document is laid out. Okay, now that we have that, we have here a list of a few. So 3, 6, 9, okay, around 16. Good. Now that we have those documents, we might want to start to create our function to pass these documents and create a summarization. So first, I would create a list of prompts, or the main prompt, which is basically, the main prompt is create a summary of the following document. All right, this is our main prompt, and we might want to add that to this documents here, but I think we can just do that right away at generation time. But let's just do for one first. Here we're going to do doc is going to be documents 0, and within this document 0 we want page content, which is basically what's inside there. And now that we have these, actually let's just print them. Doc and prompt we already know. Let's just print doc. So here we have the text. Good. Now let's generate one example. So earlier we defined just generate. Okay. Let me just close this for the time being. So generate takes model, takes tokenizer, takes prompt, and here we're gonna apply a chat template to our prompt. Let's create a more elaborate prompt based on this. It's going to be okay. Actually, we can actually do it this way. Our prompt is going to be content. Oops. And actually, we don't need this doc anymore. We can just pass it here directly. And we make this into an F string. And then we define the role, which is user. And we might want to make this into a list. Okay. So there we go. Let's generate this and see how it goes. There we go. So the context of the question is quite broad. Wait. Did we run this correctly? Did it work? Let's print this prompt, perhaps. Okay. All right. It works. So perhaps adding some quotes around it might help. So let's go. Although this model is quite fast running locally, it can take a while, especially if you're using an older version like an M1. I think an M2 or M3 might be even faster than this. So props to all of you that have a more advanced laptop. So it actually now worked. Here we are. Sure, here's a summary of the document. The paper introduces Gemma, a family of models based on Google Gemini models. These models achieve strong performance across various benchmarks. Oh, there we go. There we go. Actually, we can make this look better by using preprint. And let's see. I think this could look much better. I didn't have to generate again. I could have just passed it into an output and then didn't need to generate, but whatever. There we go. So here's the summary of that page. Sure, here's the summary of the document. The page introduces. Awesome stuff. So now let's make this better. We can now create a for loop. So for prompt in prompts. From prompt in prompts, or even better, we can pass that prompt at. Okay, but let's just make it simple for now before we go into more advanced. So here we're gonna add a list which is gonna have all the summaries. Yeah, we can call it that, summaries. and make that into a list. And this list is just gonna take whatever we get here and append it. Okay. And okay, we get a prompt there. What's wrong? Interesting. Okay, it works. So now we can create this list by doing for documents, for doc in documents. Okay, we might not need to do this list again, and now we will have our list of prompts. So this should work. So prompts, there we go. We have a prompt for each page. Good. And it's in order. It's already in order when you load, so it's fine. Now we can generate all the mini summaries. The idea is to create summaries of each page and then take the final summary of all those pages, create a single summary, like the major summary you're gonna do. This can save you like the tokens. So meaning our context window here of this model is around 8K. So by creating those smaller summaries, we might actually not fill up the entire 8K, which is good. And it's also a naive approach to generating summaries. So you create smaller summaries and finally you just aggregate everything at the end. So now we're just gonna create the summaries and let's go. So there we go. This might take a while, so I will just cut it to when it's done. Oh. Okay, there is a bug. So there is a bug. There we go. We can just fix it, I guess, this way. That might actually fix it because this apply chat template expects a list. Let's restart this. Now we're talking. Now it's going to work. Okay, so I noticed that when you get to the final pages where you have a lot of citations, like paper citations or references in this case, the model starts to generate summaries of the titles of those references. So what I'm going to do now is to regenerate everything, but I'm going to remove those pages. I guess that's from, let's see. So from what page is this? Okay, let me check. What page is this? So we can check from the document that starts on page. Yeah, this document has a lot of citations. So everything after page 10 is we can drop everything after page 10. Okay, so we can just say for the first 10, 09, yeah, 9, not 10. So let's restart this. And perhaps now, actually I want to add TQDM. Just to know where we are, import TQDM. Okay. Actually, I don't want verbose to be true. Yeah, I had to restart a couple of times because my MacBook's memory is overflowing, so it's kind of just crashing the kernel. So here I'm just gonna rerun everything except a few things, of course. We're gonna get the document, create the prompts, and now we can run and we can check our progress. So let's see. Yeah, so it takes a lot of time. I think you saw that previously 14 minutes in our previous run. You could argue that I could just make the calls in parallel, but I don't have enough horsepower locally. If I had an MX, let's say M1 Pro or M1 Max, perhaps I'll be able to do that. But I have the base M1, so I have to do it sequentially. That's why it takes a little bit longer. But if you do have a bigger computer, you can definitely run these in parallel. So here we have the first one is done. It took around the minute. So if we say so it's gonna take around 9 minutes to run all of this. So let's just wait until the end, and then we are going to actually instantiate the bigger model, so the 7 billion parameter model, to create the final summary. So we take this 2 billion parameter model, the smaller one, create summaries of each page, and then we take the bigger model to which is more, it's like more powerful, more cohesive, and it will generate the final summary. There we go. It was actually a bit faster than I expected, so let's look at them. Summaries. Okay, so most of them start with sure, and sure, here's a summary of the document. That's not fun. Let's see. How many characters do we have here? And actually, I wanted the length of this. Guess I'll give it a bit of space. Do they have? Yeah, I think I'll give it just space, or a new line would be better. So there are 10,000 characters. That's not good. It will not fit into the memory of the model, but we can perhaps partition these in 5,000, in chunks of 5,000, and then do that, or we can just drop the rest. I think the meat of the paper is earlier on. Okay, or we can create even more summaries of these summaries to then merge. But in this case, let's just take what we have. Is there a nice way? Yeah, we can take the splitter. Let me just check how I can use this with normal Python. LangChain. Okay, split. All right. You just create more documents, or split text does what I'm looking for. So we can take the splitter that we already have. Oh no, we have to create a new one. This one is used within. Okay, so now that we know how many characters are there, we can come here, just say characters, number of characters. Since we have a context window of 8K, so we can actually just divide, we can say put 7, and then we can instantiate the text splitter, split text, and actually we are gonna take this thing here. Yeah, we can now do we can create a new variable. Summaries text. Okay, so we have all those summaries in one place. Here we are going to join these two. So let's see, text splitter. I think it did the job. I guess if we just take the first one and we can actually just check the characters of the first one. There we go, it has around 6,000, which is good. Now we can create a summary of the first part. Okay, so we can just overload this here. Summaries, not text. This would have to be in the normal summaries. Split summaries, split summary, just not to overload anything that we might actually come back to. Okay, now we can actually reuse this code and generate a smaller summary. But do we want to use the bigger model to generate those two summaries? Or yeah, we actually just need to create a summary of the first part, so we can reuse this, and instead long summary, we are gonna take this long summary, and basically what we are going to do is take the split summary. We take the first one, which is the longest in this case. Okay, we need to create the prompt style. So I'm just going to say, call this prompt for long summary. And in this case, we have this one here. This is the content. So we are going to write here content, and that's okay. Okay, we want to generate a summary of this, so we can just, we can say, give me a summary of the following document. We can make this prompt a bit more robust and ask it to not say, sure, here's the summary, but I guess that's fine for now, just for demonstration purposes. Role user. Okay, and we just get this prompt here. There we go. And let's generate it. shouldn't be maximum, so we are gonna convert now. Let's just give it at most 3,000 tokens. That's gonna be the max we will generate. So we are kind of taking the 6,000 tokens and trying to fit them within 3,000. Of course, when you set max tokens, this might cut off the result, but that's fine. When you're doing summaries, you always expect some information loss, because it's kind of implicit. You're taking the full context and distilling it down, so you'll always lose a little bit of accuracy, but that's fine. So let's wait whilst this finalizes. Okay, so our summary, to generate the summary only took a minute. We can check it. Preprint will give us a better idea of how this looks like. So let's see. Okay, it's pretty, it's short, it's not that big. It gave us the main points. All right. Yeah, it gave us the main points, the 2 billion and 7 billion. So now we can join this long summary plus this second part, and this should give us, let's see how many tokens we will have once, or characters we will have once this is done. So we will have around 5,000 characters. Wait, let me just quickly calculate this. So before we had 10,000 characters. So 10,000 characters and divided by 4. This could all fit. So actually, that was my bad. So number of characters, this is approximately, in my case, it's approximately 2,621 tokens, which is fine. Actually, we didn't need to do all of this again. We can just here we can create the list that's going to be split summary, the first one, or just summary of text. Oh no, actually we don't even need to pass all of this. We can just pass directly the summary text, which has everything, and this is going to actually become the final summary. So before that, we need to delete the existing model and tokenizer to free up some space for the next one, which is just basically, we can copy this down here, put it here, and then just change from 2 to 7 billion. And now we can load the 7 billion model. Hopefully it loads without crashing. There we go, it loaded. Thank God. And now we can generate the final summary. We can say maximum, I think 1,000 tokens. 1,000 tokens is okay. Let's generate following document. let's generate our final summary. This might take a bit long, but let's prepare the printing here. There we go. So the 7 billion version runs at around 4 tokens on my MacBook, but because I'm using a lot of things right now, it might be a bit slower, but let's see how long it takes. There we go. So it took about 5 minutes to generate the summary of this around 2000 plus tokens. So now let's look at the summary. It says summary of the document. This document summarizes the key points of the paper. Okay, so it actually took verbatim what this thing was saying. Well, the previous summary. So it took here Shor describes the Gemma family of models. That's good. Key highlights: Gemma models achieve strong performance. That's correct. 7 billion and 2 billion. That's correct. Independent developers, malicious actors fine-tune Gemma for. Okay, it's an okay summary. It's not like GPT-4 level or Mistral 7B level, but it's okay, and it makes sense because the previous model generated summaries with a kind of extra words that weren't really necessary, and it was a smaller model. Perhaps if we had run everything with the 7 billion, it would have been better, but that's fine. This is just to kind of showcase the power of these models and what you can do. Now imagine if the previous model was fine-tuned to generate highly coherent and cohesive summaries, that would have been even better. So think about how you can fine-tune these, and I will show in a future video how to fine-tune these models. Now let's move on to the last part of this video, which is another interesting thing that I learned about MLX today, is you can actually run your own server that comes with pretty much OpenAI API compatibility. That means you can actually use the OpenAI library to run this locally. But in this case, you can run it easily by copying this code here and using it on your terminal first. So let me get my terminal. There we go. I need to activate my environment, which is LLM fine-tune. So once we run this environment here, it's gonna get the model and run the server. There we go. It started the server. We can come back here under requests, right? We can actually just keep this half the window so you can see. So under requests, it just takes a URL, a header is application JSON. It uses the same format as we used previously, the role and content. Actually, this is not needed here. Role and content, and I'm just asking hi, temperature 0.7, max tokens 100. And I'm just using the requests library. And here I'm printing the result and excluding the end of sequence token, which comes by default. And also you get the usage, so we will be able to see this. So if I run this, you can see here that the server got the request. And now we have here the response and the usage. So the response is, hi, it's nice to meet you. How can I help you? And the usage is around prompt tokens are 9 tokens and completion about 17. So 26 tokens in total. So this is one of the few things you can do with this library. Of course, you can also run curl requests, normal curl requests. You would still get your response, and here it is. So this is what you can do running Gemma with MLX locally on your computer. Of course, you can also use it with libraries, projects like Ollama, LangChain, and even transformers if you have like GPUs, any NVIDIA GPU. So this is it for the video. Thank you.